This is the Daily Space for today, Monday, July 20th, 2020. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. Welcome back, everyone. This is the most Monday of Mondays. For everyone around CosmoQuest, we're still a little, hungover in content from hosting our CosmoQuesticon. After experiencing 2.5 days of amazing content, our brains are on overload. Now, it's a glorious feeling to be suffering from having learned a little too much, but also one that meant the sight of a wall of press releases this morning was a little intimidating. Yesterday, in what felt like a surprise move, the United Arab Emirates took advantage of a sudden, it wasn't that sudden, took advantage of a glorious hole in bad weather and launched on a Japanese rocket the Al-Amal or Hope mission on its journey to Mars. This is the first interplanetary mission from any Arabic-speaking nation, and it is the first Mars launch of 2020's launch window. From space explorers and procrastination, we now turn toward that pile of press releases. It seems that our current global pandemic is even starting to affect the science writers. The MIT press release on our first story starts, "It seems the universe has an odd sense of humor. While a crown-encrusted virus has run roughshod over the world, another entirely different corona, about 100 million light years from Earth, has mysteriously disappeared." You okay, MIT press release person? We're here for you. It's getting to all of us. In space-related sciences, a corona is the region of superheated gas surrounding an object like our sun, or a black hole in this case. Objects that have the same spiky surrounding structure like coronaviruses get their names from the much bigger and meaner celestial origins. In this case, the corona in question is the biggest and meanest corona of all. It is the corona that surrounds a galaxy's supermassive black hole. In a new paper published in the Astrophysical Journal with lead author Claudia Ricci, astronomers document the fade away of the X-ray corona of the galaxy 1ES 1927 plus 654. Using the NICER X-ray Observatory on the International Space Station, they say this system faded by a factor of 10,000 over just 40 days. And then, after 100 days of quiet, it rose back up to be 20 times brighter than before. The corona around supermassive black holes in galaxies is created by material getting superheated as it falls into the black hole via an accretion disk. And the best way to explain this kind of a temporary fading is through the disruption of a star that disrupted that accretion disk. They theorize that a runaway star may have wandered too close to the center of this galaxy and been disrupted by the supermassive black hole, and its debris may have in turn disrupted the accretion disk. According to Ricci, we just don't normally see variations like this in accreting black holes. It was so strange that at first we thought maybe there was something wrong with the data. When we saw it was real, it was very exciting, but we also had no idea what we were dealing with. No one we talked to had seen anything like this. Eric Hara, a co-author on this research, went on to add, "This dataset has a lot of puzzles in it, but that's exciting because it means we're learning something new about the universe. We think the star hypothesis is a good one, but I also think we're going to be analyzing this event for a long time." Folks, astronomy can be super frustrating. We can't run experiments or recreate galaxy-spanning events in our labs. When we see weird and rare events, it's thanks to the luck that we just happen to be looking in the right place at the right time. And the one data set we collect may be the only one we ever get to collect. Well, the idea of an infalling star is a solid one that fits the data. We may never know if this is what actually happened. All we know for sure is that a supermassive black hole's accretion disk, 300 million light years away, had something happen that caused its corona to disappear for 40 days and come back brighter than ever before. This idea of a runaway star, it actually isn't all that far-fetched. We see runaway stars periodically. And stars can get flung hither and yon through a whole variety of different processes. And in a new paper in the monthly notices of the Royal Astronomical Society, lead author Boris Gansik and his team look at a truly odd star that has been caught fleeing at breakneck speeds across our own galaxy. This object is traveling at 900,000 kilometers per hour and appears to be the survivor of a supernova explosion. This star is tiny, even for a white dwarf. Physically, it's roughly the size of the moon, with a mass 40% that of the sun. This is a small, dense object, and it is small even for a white dwarf. Its surface appears to be composed of an unusual mix of oxygen, neon, magnesium, and silicon, with a side of carbon, sodium, and aluminum. All of these elements can be produced in the thermonuclear reactions that go on at the beginning of a supernova. According to Gansik, this star is unique because it has all the key features of a white dwarf, but has this very high velocity and unusual chemical abundances that make no sense when combined with its low mass. It has a chemical composition which is the fingerprints of nuclear burning, a low mass and a very high velocity, and all these facts imply that it must have come from some kind of close binary star, and it must have undergone thermonuclear ignition and just not followed through with the complete explosion we might have expected. It would have been a type of supernova, but what kind of supernova, we don't know. We haven't seen this kind of thing before. If it was a type binary and it underwent thermonuclear ignition, ejecting quite a lot of its mass, you have the conditions to produce a low mass white dwarf, the unignited coal getting ejected from the system, and to have it fly with its huge orbital velocity that we currently see. To get this kind of an event, two stars need to be in a close binary where a white dwarf can feed on its companion star until it reaches a mass at which it can ignite as a supernova. In this situation, however, it appears that ignition was incomplete and worked more like a nuclear bomb-powered rocket, which is something you really don't want to try, but you can. It looks kind of like a nuclear-powered bomb was attached to this white dwarf star and sent it hurtling through our galaxy. As the press release summarizes, this star, SDSS J1240 plus 6710, may be the survivor of a type of supernova that hasn't yet been caught in the act. Without the radioactive nickel that powers the long-lasting afterglow of the Type 1a supernova. This explosion that sent SDSS 1240 plus 6710 hurtling across our galaxy would have been a brief flash of light that would have been difficult to discover. Our universe is a weird, weird place that is often very confusing. Trying to get a handle on all that is going on takes a myriad of telescopes that work from on the Earth and from in orbit around the Earth. We use them to try and build as complete a picture of our changing universe as we can. Today's news so far has covered X-rays observed with the NICER telescope aboard the International Space Station, optical observations from a myriad of telescopes, including the Hubble Space Telescope. And now we're going to look toward the microwave and a new paper posted up on Archive and shared out by the Simon Foundation that uses the Atacama Cosmology Telescope to look at the small-scale variations in the polarization, the way light scatters off the cosmic microwave background radiation. They use these measurements to try and determine the age of the universe. They estimate an age of 13.77 billion years, give or take 40 million. And this is an age that's consistent with the age that was determined by the Planck telescope and is not consistent with studies that looked at the more local universe using supernovae. Their measurements would correspond to a Hubble expansion rate of 67.6 kilometers per second per megaparsec of space. While this new paper with lead author Simone Olia stresses that these results are accurate, match Planck, and point to an older universe, these results don't match observations based on observing the expansion that has been taking place in the more recent few billion years of our universe. These models are coming up with a universe that is substantially younger and expanding faster. Now, as often happens in science, this paper comes out at the same time that a bunch of research that could have informed this paper is also coming out. In a different study, looking at the expansion rate from the perspective of galaxies, including distant quasars, new research that I just couldn't make through this morning because it was dozens of papers and more than 500 pages of information, in a data dump of new papers from the Baryon Oscillation Spectroscopic Survey team. They present analysis of galaxies and galaxy clusters and quasars and anything they could observe over the past 11 billion years of the universe's history. And they look to study that changing, it now appears to be changing, expansion rate of our universe. Using data from the Sloan Digital Sky Survey, they find once again, this time not using the cosmic microwave background radiation, that the expansion rate in the early universe is 10% lower than the value found from the distances to nearby galaxies. According to team researcher Eva Marie Mueller, only with maps like ours can you actually say for sure that there is a mismatch in the Hubble constant. These newest maps from EBOS, that's their long acronym, show it more clearly than ever before. As is pointed out in the press release, there is no broadly accepted explanation for this discrepancy in measured expansion rates, but one exciting possibility is that a previously unknown form of matter or energy from the early universe might have left its trace on our universe's history. This is a tremendous result. They have now matched what the cosmic microwave background studying teams have been seeing using a completely different kind of study. I'm going to be digging into these papers in the coming days, weeks, and probably months. It's 500 pages of research, folks. 500 pages. Prior to this moment, we had two data sets. One for the early universe, looking at cosmic microwave backgrounds. One for the current universe. That older universe study showed, that the universe has been around for longer and is accelerating apart slowly, as compared to what we see when we look at the nearby universe, which appears to be expanding quickly, which would imply a younger universe. This is a discrepancy. Something changed. We have data sets spanning these two epochs now that make it clear the universe's behavior has changed over time. I no longer know exactly how old our universe is. I can say with confidence it's somewhere between 13.5 and 14 billion years old. I think that's an accurate statement. But everything else is a bit uncomfortable of a mess. And this is a lot for a Monday morning, people. This is a lot. Rather than end on this uncomfortable note, I'd like to turn for a moment to some really beautiful astronomical sleuthing and the work of Donald Olson, Russell Doscher, and Doscher's students, who have been working to understand exactly when Johannes Vermeer painted his famous View of the Delft painting. This Dutch city is now a wild tangle of cars, bicycles, buildings old and new. You can go visit it and see some of the structures visible in this painting even today. But the question has been, given the mixture of sunlight and cloud, when exactly was this painting painted? And what's kind of amazing is after traveling to Delft, they were able to figure out the location where this was painted. Look at the shadows, look at the light. And they're now able to say that this painting captures roughly 8 a.m. on or about September 3rd. And it's estimated this painting was painted no later than 1659. So we now know very precisely what Vermeer was seeing when he captured this light. This painting was done from a second floor inn that overlooked the city. They were able to sort, this team of researchers was able to sort sight lines and angles and determine where and when they needed to be to capture the data they needed to finalize their understanding of this painting, thanks to the available tools within Google Earth. Yes, folks, you can do really cool research using Google Earth. This is just the latest in a long series of paintings that Donald Olson and a myriad of different collaborators have worked to scientifically understand. And these paintings and the science they have revealed have appeared across several decades in series of articles consistently appearing in Sky and Telescope magazine. This is just cool. This is just cool. And this is where we are going to end for this Monday. This is all the science we've got to share for today. This has been The Daily Space.